Hey everyone, this is Josh Wang and Grace Cal, and we are here to demonstrate our Boyd simulation that we've made for Lab 6 in computer game animation. So just to start, I will go ahead and start our simulation, and we'll just let it run for a little just so we can show you guys.
So as you can see, these are our Boyd implementations with the three factors: cohesion, heading, and avoidance. So for the Boyd cohesion, these Boyds tend to flock together. The Boyd heading, it's just basically facing the same, or the Boyds tend to face the same direction. And then the cohesion, if you see the three sliders on the screen, you have cohesion factor, heading factor, and avoidance factor. And if you drag those, it just changes all factors.
Yep, and so our third factor is avoidance, and that one's a bit special. And so that's basically where the Boyds will tend to avoid other Boyds that come closer, and we've kind of adjusted it so that similar colors will avoid each other less, and so you can kind of see some of the greens and some of the blues are starting to stream together more because they have a lower avoidance factor amongst each other. And so like Grace said, you can also adjust the factors here. So if we go ahead and raise the cohesion factor, you can start to see that the Boyds will clump together more. And so if we lower the cohesion factor and raise the avoidance now, you'll see that they'll start to split apart and kind of flock together less. They'll just be more sporadic in general. And let's go ahead and equalize those and kind of raise the heading factor. And you'll start to see that all of the Boyds will tend to face in the same direction with their immediate neighbors. And this will be a lot stronger than before. Yep, so that's just some of our changing factors.
And then now we want to talk about the effects that we have implemented. So each Boyd has an emissive glow, and each Boyd also has different colors. So we just used emissive material for this.
Yep, and one of the other effects that we've implemented are trails, as you can see on the screen. So as the Boyds kind of fly around in this 3D space, they will emit these glowing trails that kind of highlight the paths and the patterns that they tend to display. Another thing is we've added some ambient music in the background just to complement the simulation effects that we have. And so as we see our Boyds fly around in our simulation, this actually takes place, as you can see here, in this predetermined game area, which is just a box bounded by 6 cubes. When we start the simulation, the Boyds will start spawning in this game area, as you can see here. And so each Boyd will spawn with a random position and a random starting heading within the game area.
And then we also implemented teleporting. So if a Boyd touches one wall, it just teleports to the adjacent wall. This is just to keep all the Boyds in the enclosed area so that none of them are escaping. And then if you go to the top left corner, you can see a game area radius. This is where you can enter a specific number, and then based on the number, it changes the game area based on however you want it. So if you enter 5, you can see that the container adapts to the number. 10, the Boyds are farther away, and 30, the Boyds are just very spread out.
Yep, and so one of the things that you may notice between, let's say if we go back to 5 and we let it zoom in and we go up to 50, is we've calculated our camera offset so that our horizontal field of view will perfectly encompass the game area, and it'll kind of smoothly move between the two whenever they change. So once again, we can see that effect if we move to a smaller container from 50 to 15. You'll see that it starts zooming in here slowly, so it'll ease the viewer into the new game container. And that's kind of all we've implemented for our Boids simulation here. We hope you've enjoyed it, and we'll just let it play for a few more seconds. So we hope you enjoyed our presentation, and thank you so much.
Thanks, guys.